Hello guys, welcome to watch our video. As you see, we are going to talk about the concavity and the second derivative test. What is the meaning of concavity? It means the curve open upward or open downward. Okay. Here, before I begin this session or this lesson, I have to revise with you some things very, very important. Look with me here. As you see for this graph, okay? Here at this point, okay, A, we have what? Relative maximum. Since we are talking about the extrema on an open what? Interval. Open interval. It will be relative. Here at this value, we name it, I say B. It is what? Relative minimum. I think it's easy. At this relative maximum or relative minimum, the slope of the tangent equal what? 0. Or by another way, the first derivative equals 0. I just revised with you what we learned in the previous quarter. Here, the behavior of the function here, okay, from negative infinity to a is what? Increasing. Why? As x goes to right, y goes to up. Here, the behavior of the function is what? Increasing. And we learned before, we have a relationship between the behavior of the function and the sign of the first derivative. Since the function is increasing, the first derivative is what? Positive. Is what? Positive. Okay? Look here, as you see in this case, from A to B, the behavior of the function is what? Decreasing. As x goes to right, y goes to down. Here, the behavior of the function is what? Decreasing. And as you know, also what we learned before, the first derivative is what? Negative when the behavior of the function is increasing. Okay? I'd like to tell you something new. Here, as you see, the first derivative changes from positive to what? Negative. Positive, 0, negative. So the first derivative is what here? First derivative is what? Is decreasing. Since it changes from positive to negative, it will be what? Decreasing. As you see the curve here, it open what? Up or down. Here, open up. So concavity up. Sorry. Up. If the curve open downward, this means the concavity is what? Downward. Because the concavity tell me the curve open up or open down. Okay? Since the first derivative is decreasing, the function is concave. The function is concave what? Downward. Decreasing, so the concavity is what? Downward. Let's discuss about the behavior of the function and the sign of the first derivative on the other part. Here 0 and here negative, but here what is the behavior of the function is what? Positive. Is what? Positive. Okay, and as you see here, the first derivative changes from negative to positive, negative 0, positive, negative 0, positive. So changes from negative to positive, it means the first derivative is what? Increasing. What? Increasing. And as you see, the curve of the function is what? Concave upward. Concave upward. Here, that is the concavity. Open to up. Concavity upward. I think so trivial. So, as you know, sometimes a curve of the function, it has a part concave upward, sometimes it has a part concave downward and for the same graph of the given function. Okay, that is our lesson today. When the function concave downward, when the first derivative is what? Decreasing. Is it decreasing? Changes from positive to negative. That is the concave downward. When the first derivative is increasing, it means changes from negative to positive, so or by any way, or decreasing, increasing. In this case, if the curve of the function is concave upward, on this interval. Okay, let's begin our lesson. Here, that's the definition of the concavity. Definition of what? That concavity. Let f be differentiable on an open interval I. The graph of f, the given function, concave upward on a given interval if the first derivative is what? Increasing on this interval. Concave downward if the first derivative is decreasing, as I showed you before. Look here by the symbol. Here, since the function here, look with me, the slope of the tangent, as you know, the slope of the tangent, it means the first derivative. Here it was negative, and here it will be 0, then positive. Okay, the what? 0. It means increasing, so the curve of the function concave upward. And as you see, the curve of the function here above the tangent, or the tangent line below the curve of the function. And here, as you see, that is what? Here it is positive, here 0, positive, and here negative, the slope of the tangent. As you know, the slope of line here, it means positive. The slope here is what? 0. Slope here, it means what? Negative. Understand? Okay. Let's continue. Here, test for concavity. How I know the curve of the function, given function, concave upward or downward analytically. Yeah, it means if you give me just the rule of the function, and you ask me to find the interval in which the function concave upward or downward, I'll apply this test. Look here. Let f be a function whose second derivative exists. Okay, on an open interval. If the second derivative for all values in this interval more than 0, so the curve of the function concave upward. If the second derivative positive, it means the curve of the function concave upward. If the second derivative less than 0 for all of the values of x in a given interval, this means the curve of the function concave what? Downward. Okay. Look here, I'll show you 4 shapes of the function. Look here, this one. Okay, this one. This function, or this function. Look here. No, I don't want this one. Wait a minute. Sorry. To give you 4 different cases. Okay. This one. Like this. This curve, please focus. This curve, the function here is increasing or decreasing. It goes to right, the curve goes up, it means the function is increasing. Is what? Increasing. So the first derivative is positive, more than 0, or I can write in that it is what? Positive. Understand? When the function is increasing, as we learned it before, the first derivative positive. When the function, its behavior is decreasing, the first derivative is what? Negative. That is to decide the sign of first derivative and second derivative. Look here, the curve of this function concave downward. What is the meaning of concavity? Open, open what? Downward. Up and downward according to the theorem that I just give you. The second derivative is what? Less than 0 or negative. Concave downward, this means the second derivative negative. For the next curve, look here, as you see, for this curve, as x goes to right, y goes to up, it means the function is what? Increasing. Okay, if the function is increased, so the first derivative is what? Positive. This curve concave upward or downward? Upward, so second derivative is what? Negative. Here, as you go right, y goes down, so f is decreasing. If the function is decreasing, so the first derivative negative. Okay, since the curve of the function open downward, it means concavity downward, so the second derivative is what? Negative. Okay, for the last shape, for this last shape, wait. Okay. As you see for this, that is shape 1 or graph 1, graph 2, graph 3, that is graph 4. That is the given curve. As you know, the behavior of the function here as x goes to right, y goes down, so the function f is what? Decreasing. Okay, since the function is decreasing, so the second derivative is what? Negative. And since the curve open to upward, so the second derivative is what? Positive. I think it's so trivial. Okay, I solve with you the following exercise, only part 1 and 4, and you will solve number 2 and 3 as a homework. That is number 1, that is number 4. What is the head of the question? You have to read the head of the question well to understand what is the request or how to solve your problem. State the sign of first derivative and the sign of the second derivative on this interval for this given function. It's so easy. First derivative, second. Here, the behavior of the function tell me the sign of the first derivative. Goes to right, up. Since the function is increasing, so the first derivative is what? Okay, since the curve of the function concavity upward, or the curve of the function open to up, second derivative is what? Positive. I think it's so tricky. Tell me the first derivative, the sign of the first derivative, the behavior of the function. Of the function, okay? Here, as you know, as x goes to right, y goes to up, since the function is increasing, I'm sorry. Okay, I'll solve number 2 instead of number 4, and number 3 and 4, it will be. Okay, the first derivative here, it will be what? Positive. Okay, concavity, the sign of this one from the concavity, since the curve concave downward or open to downward, so the second derivative is negative. I think it's so trivial, so trivial. Now, let's solve the next one. Look here. So trivial. Determine the open interval on which the graph is concave, upward or concave, downward. Follow the steps. Okay, the first step here means I use the second derivative test. I use the second derivative. In this case, I use what? Second derivative. When we talk about interval on which the curve is concave upward or downward or something later I'll define which is what inflection point, I use what? Second derivative test. Okay. Look here, to find the second derivative, I have to find first the first derivative, which is what? Y prime equal 2x minus 1. Okay, second derivative, use the second derivative test. Okay, I have to use the second derivative. It will be what? 2. As you see here, this function is constant for all the real value. Okay, clear or not clear? Since it is for all real number, and it is what? Positive more than 0, so concave upward. The curve of this function concave upward. On which interval? All real number, it means from negative infinity to what? Infinity. In this case, we say the function or f is, wait a minute. So the function f is concave upward on all of the real numbers on negative infinity to infinity. I think it's so trivial. Okay, I use the second derivative to identify the interval on which the curve of the function concave upward or concave to downward. Let's solve the next problem. Number 9 and number 6, 7, it will be homework. Okay. What I have to follow the steps. Yes, I use the second derivative test, but I can find the second derivative without finding the first derivative by applying the rule of differentiation. Okay, it will be what? Negative 3x squared plus 12x minus 9. First, find the second derivative. Because I use the second derivative to identify the interval on which the function concave upward or downward. It will be negative 6x plus 12. Okay, then find the zeros of second derivative test, or where it is what? Undefined. Plus 12 equals 0 implies x equal 2. Fourth step, as I did before with the first derivative test, I do with the second derivative test. Use the line for what? Be careful. Second derivative. Concavity, second derivative. Right here, the zeros of this second derivative. Here, negative infinity, and here what? Infinity. Test value. Did you remember the test value? I use the test value, which are here, the values are included in each of these intervals. The zeros of the second derivative divide the domain into 2 intervals. Okay, here I'll choose 0 or 1 or any values less than 2. And here I choose what? 3. Replace in the second derivative. Don't forget, I use second derivative. Replace in the second derivative. Concavity, second. It will be 12, so it will be positive. If we replace 3 here, it will be negative. Plus 12, negative 6. I care about the sign, not the value. Since the second derivative, positive, okay, on this interval, -2 to 2, negative infinity to 2, positive, it means concave upward. Negative, it means it is concave downward, according to the theorem. So, F is concave upward, okay, on which interval? Negative infinity to 2. F is concave downward on which interval? 2 and infinity. I use the sign of the second derivative on each interval to decide the concavity. Please don't forget, when we ask about the concavity, we use the second derivative test. But when we ask about the increasing, the behavior of the function increasing or decreasing, we use the first derivative test. Okay, thank you for joining this session and have a nice day. Bye-bye.